Good morning, everyone. Good afternoon, good evening from wherever you're joining us. Welcome to the Keshe Foundation Spaceship Institute's public teaching. And today is Monday, September 25th, 2017. Today is our first week of the Understanding Plasma Science series. This is a brand new series that we're starting here. That's going to cover the basics of plasma science. And today, the topics are plasma science, nanotechnology, and GANs. And our presenter is Jim McDonald, and he's going to be here every Monday with us for the next 12 weeks. So welcome, everyone. I'm your host, Flint Smallhausen, and welcome, Jim.
Thank you, Flint, and thank you for everybody else attending today. Now I'm just going to start sharing my screen. There's always a few seconds before it actually comes through and changes. All right, so good afternoon, everybody, and wherever you are in the world. The purpose of this workshop, a series of workshops, is to try and get to the core understanding of what this plasma science is all about. And as we've broken it down into 6 topics, and the whole point of these workshops is we're going to start doing the very basics, and every week we will build on this knowledge. So we're only going to be introducing a few concepts at a time every week, but they are important concepts to understand. And then you'll be able to see how, by understanding the science, how it starts interacting and relating with the other aspects. So the health, the body, the nature, the plants and the trees, and ourselves with the soul. So it's all interacting and all linked. It all comes down to the same basic principles of how the plasma operates. So hopefully in doing this, we will at least give a lot of people, particularly the new people, an opportunity just to get their mind around what this technology is all about, because there's such a huge amount of information. So if we can just impart the basic knowledge behind it, then at least it's a great stepping stone for you to begin and start studying further. So when you hear my pause, you know I'm just waiting for the next slide to come through. So this technology is going to change the way that we understand everything in the world around us. We'll begin to understand how space travel is possible. We'll begin to understand how we can really change the health of our body, create different materials, have energy that is always available without destroying anything. And you look at transportation, the environment, agriculture, and nanotechnology. So it's a really all-encompassing technology. It's something, it's more of an extension of what we have learned up until now. Today's workshop, being part 1, we are just going to do an introduction on what plasma science is. We'll do an introduction on nano and an introduction on GANs. And then obviously every week thereafter, we will start and build on this knowledge. This technology is brought to you by the Keshe Foundation, and 2 websites that are available for further information. And the founder of the foundation, Mr. Keshe, is one imparting this knowledge to us. Okay, so we're going to start off with the first section. What I'd like to do is go through the first section I will then open the floor to questions, just a few questions. And please keep your questions relating to the topic that was presented for the day. And then we will move on to the next section. Okay, so I'm going to start off with a few quotes from Mr. Keshe as an introduction into sort of the understanding of what this new science is all about. So when we look at it, the last century was all about the matter state. Then we developed the nuclear and atomic knowledge. And now we have gone a step further into the fields, which make the electrons, protons, and everything else we see around us. We fought the matter for thousands of years, and we couldn't manipulate it anymore. The maximum we got was making of alloys. The maximum we've been achieved is taking this matter state and mixing it with different metals and creating different alloys, but we've still been working in the matter state. And the maximum we got was the tangibility of being able to see something and hold on to something. And that's what we've been told is the matter state, what we can see. And in the chemistry world, we mix things together, and that's as far as we have gone as well, mixing the different chemicals and creating different compounds. When the world was introduced to the atom 100 years ago, it was something new that we had to accept. And then we began to move into the nuclear era. And because of the Hiroshima bomb, people got to respect this out of the fear and not the knowledge. And now we move into the plasma, and it is peaceful, and it shows us its power with no fear. So the plasma science is beginning to understand about the knowledge and energy of the universe. If we can begin to understand how the universe works, we will know how Earth works, we'll know how our body works, because it all works in the same way when we understand the basic principles of this science. So when we start with the matter state, this is something that we all know. It's something that's been around for thousands of years, and that's what we understand in our current science is the matter state. And we try to use it and manipulate it in different ways, but it's still essentially the matter state. What we will show you during the course of these workshops is how to create, taking your matter state, and how we're going to create nano layers on the matter state. So we're taking the matter state that one little step further in creating the nano layers. We will then learn how to use these nano layered plates to start making your own Gans materials. And from understanding and working with the Gans materials, we have begun to understand that we are really working with the fields that is generated from these Gans materials. So it's a whole process, starting from the matter state, creating the nano, creating the Gans, and essentially now beginning to work in the fields. Now, when we talk of the fields, they're all around us. We don't see these fields, but we know that they do exist because we've all had X-rays, been to the dentist or the doctor, and we've all had X-rays. And those X-rays are using a certain strength of field. We don't see them, but we know that they are there. We are very aware of the nuclear radiation and its effects, yet we don't see these fields either. These are also a different strength. We see the visible light, but we need special equipment to see ultraviolet light. So light is also a different strength. So we know that there are some fields around us that we don't see. And so this technology is just a way of us understanding that there's more and more around us than what we have discovered so far. So we just learn to go through the various steps to release these fields and use them and start using these fields in all applications of science. And then in return, we've begun to learn that from the fields, we can make the Gans material, just like we've been taught to make CO2 Gans, which is essentially produced from the fields around us, to the nano and matter stage. So from the fields, we can then begin to realize that we can start making and create matter, any matter that we want using the fields. So we will learn how to tap into this energy and understand the fields of the universe. And in so doing, we will then discover a new way of living on this planet and beyond. So this new understanding of the nanomaterials, the Gans, and the fields is what plasma science is all about. And these fields are magnetic fields. Everything in the universe is made from magnetic fields and their interactions. From the smallest atom to our body to the universe, all are made from these fields. So it's from the ones we see and the ones we don't see. So we know that they are there, but we've just never been able to measure and have instruments to be able to understand that there are far more than what we have known. So the existence and interaction of dynamic and different strengths, speeds, and densities of magnetic fields lead to what we see as the planets around us, our galaxies, the plants, the animals, the molecules, and the atoms. Essentially, everything is made from these fields. And when we look at the spiral of the plasma, if one can imagine, this is viewed as a wound-up spring, so that we know in the very center would be the strongest point. And as we work our way out to the very outside of the spring, we get to the very weak state and weak strength of that spring. And when you have a look on the right there side, that's the matter state range. So we're right on the edge. That's where we've been playing and working with for the last thousands of years, is in the matter range. When you move into the center, you get the visible light range and the X-ray range. And this is what we've been working with and what we've understood current science at the moment. So now we begin to understand that there are far more different fields out there. And so we are learning to use them and understand them. To understand these fields, we have to understand another basic concept of understanding the magnetical and gravitational fields, or what we will commonly term as maggrav fields. We've all played with the square magnets our whole life, and it's a case of understanding the different terminology now that we're going to be using. So when you have two square magnets, where the fields have been dictated in those metal magnets, where you have a north and a south, the entry point and an exit point. And so when you bring the north and south together, the magnets will attract each other. And that's what we would term as gravitational, because it's the pulling together. When you have the same polarity at the bottom there, north and north, the magnets will repel each other and push each other away. And that's what we will term as magnetical. But this is only in the square magnets that we get these essentially two directions. I've got this little video showing you the effects with the round magnets, and when you're introducing another magnet into the other two, you'll see how they will want to position themselves, and they're always maintaining this gap, a certain distance which they're maintaining. When you add another one, the others then have to find and reposition themselves. And you'll see how they just, okay. So it's very interesting when you start viewing them from the round magnet's point of view, is that they will all find their position. So we have to ask a few questions about these round magnets. Is what force is making these round magnets move? If we move one of them, what's making the other one move? And why do they seem to keep a certain distance from each other? Why do they all move if we only move one magnet? You know, if we have 3 or 4 magnets in there and we move one of them, the other 3 or 4 will move as well. You know, so why do they do that? What is the connection that they all have? And what would happen if these magnets were round balls and we'd had to do that in a 3-dimensional aspect? This is, bear in mind, this is on a flat plane. So if they were round and we could do that on 3-dimensional, one could visualize this positioning that they are doing. It's like a dance that they're all doing together. So these are the questions that one has to ask. And so when we look at the distance and the gap between the magnets, it comes down to the strength of each magnet will dictate this gap and this distance between the two. So as one moves, so the other will reposition to maintain that gap. And so we're having the magnetical in repulsion and also having gravitational on the attraction. What we're essentially having is the interaction of fields of 2 magnets. And the fields exiting the one magnet interact and into the bottom of the next magnet. And this is how that they keep their distance from each other. This gap allows them to move freely. They're still connected and find their position, but this is how they interact with each other, is through these fields. Now, bear in mind, this is all in the matter state. So we have to start, and obviously in the matter state, you're looking at magnets with iron based. When we start looking at this interaction in the plasmas, it has the same effect. You're dealing with the same magnetic fields, but from a plasma point of view. Gases. So we've got to understand the fields. So it's the direction of the flow of these fields which dictates what we call magnetical fields and gravitational fields. So the fields flowing out or away are magnetical, and the fields flowing in towards the center is gravitational. So that is the representation on a sort of three-dimensional basis if those magnets were round. We will go into, in the next further series on the workshops, exactly the formation of these magnetic fields, how they come together and interact. But what we wanted to achieve today is just how that these two interact, and at the term MagRav fields, because we will be using this terminology throughout the next presentations. And you need to understand what we are really talking about when we're talking about the MagRav fields. And it comes from the two words magnetical and gravitational. And we will then be using this in terms of sort of magnetic field strength of certain ganses and certain plasmas. But we need to understand this concept. So in summary on this first section as an introduction is plasma science is really going beyond what we have known as the matter state. So we're taking the matter state and we end up through various processes from the nano to create GANs, and we essentially get to start using the fields, which is the essence of the matter state. It's not magic. It's just something that we have yet to understand. It's always been there, but we have never understood it. So now we are just able to understand further from what we've always known in science. And we begin to understand that everything in this universe and beyond is made of magnetic fields. So that is an important point to remember, is that even your matter that you're looking at is all made of fields. And if you understand then the principle of where we're getting the magnetical and gravitational fields. So those were the two basic concepts that wanted to get across for this introduction for the plasma science, is that everything comes down to the fields, and it's how these fields interact with each other is what we see today around us. Any questions? And we'll open up questions. Please keep your questions related to the topic that we are presenting.
And any attendees, you guys can raise your hand. Sorry about that. Any attendees, you guys can raise your hand and I'll bring you in. And if there's any questions on live stream, Facebook, or YouTube, I can announce those too. Any of the panelists have any questions right now?
It's Monday morning, it's too quiet.
Yeah. Well, not for you, it's evening for you.
Yeah. All right, then we carry on.
Just looking through the other streams here to see if there's any questions. Hey, Rick. Welcome. Sure.
And turn on my mic and live stream. Yes, I have a question. So, yeah, my name's Rick Crammond, for those who don't recognize my voice. I'd like to know how the MagRav fields, these magnetic fields you've described, how does the idea of gravity work into that? What is gravity in terms of MagRav fields? what we call gravity now, the thing that sticks us to the planet at this time?
I will be getting into that in part 3 when we go back to plasma science.
Okay, good answer.
I have a question.
Yes, go ahead, Boniface. Yeah, please introduce yourself and ask your question.
Thanks. This is Boniface, California. Since this is a beginning class, maybe you want to define some of those terms like nano and GANs. I know they are acronyms, especially GANs, but if you can sort of break it down since you have few people on board, probably.
Yeah, it's a good point. I do have, when we go on to the next section on the nano and the GANs, then we have those definitions there for people.
All right, thank you.
Pleasure.
Hi, I have a little question. It's Rui from Portugal. Can I ask?
Go ahead.
The magnetic and gravitational fields, as you show, it works on in the square elements or any shape of magnets.
See, when we look at the square magnets, when we manufacture the square magnets, and that we dictate that field. We dictate what is north, what is south on those magnets when we manufacture them. When we look at the round magnets, it's slightly different. Even when they are manufactured, there is a north and a south to them. What we need to understand, and what you will get to see later in further presentations, is that when we start looking at the plasma and the Gans material, is they are essentially a round, you can explain them as a round magnet, and so they have their fields. We're not dictating their fields, if you understand what I mean, but they act like a magnet, yes. The attraction and of the fields. The square magnets, we dictate what's north, what's south. Does that answer your question?
So you mean round magnets, they play as the fields they have, right? And the other ones are already dictated, yeah?
Yes, the round magnets are also dictated. There is a north and a south to them, but because they are round in shape, it's the concept of the round shape, where no matter where you move those magnets, there's always that interaction. And if you had to view those magnets not on a flat plane like in the video, but in a three-dimensional basis as a round ball, that's what one has to visualize. Is that they are round magnet with the fields coming. So it doesn't matter which way one is turning those, there's always the fields interacting with other fields.
Yeah, that's why I made the question. Thank you very much.
Okay, I have a couple questions here. Anonymous asked here in Zoom, is X-ray plasma a field?
X-ray is a field strength. It's of a certain field strength. Just like with its beta or gamma or ultraviolet light, it's a certain field strength.
In matter, right?
What do you mean in matter?
In the matter state.
Well, we're still dealing with the fields.
It showed fields on your spiral. It showed the X-ray on your spiral graph there from the book.
But it's beyond the matter state. So let me try and. it's just understanding that any point on the spiral is a certain field strength. And we are talking of a field strength that has magnetical and gravitational, because we can't get one without the other. We have both magnetical and gravitational. So at a certain point on the spiral, it's just really a certain strength, mag-grav field.
Okay, we have another question from Dennis Dunham in live stream. Do the magnetical fields have both magnetical and gravitational fields?
It's the interaction of the magnetic fields that leads to what we know as the gravitational. There is obviously the Foundation has produced that video of how the fields start interacting, and that's how we will be touching on that and explaining that in more detail in the next presentation, is how the fields come together and how they interact. But essentially, it's the interaction of the magnetic fields which what gives us what we call gravitation. I just don't want to go too far, too fast. So it's just a very slow process just to introduce these basic concepts, because if we just go too fast, then we'll lose a lot of people. So we'll see by the end of the 12, we'll have covered a lot of sort of essentially all the questions that people do have, but we want to do it in a very slow and methodical process.
Mm-hmm. Yes, I understand. There's a Peter Heitzberg that had his hand up. I brought you in. Peter, you have a question?
Yes, I do. Are you able to hear me okay?
Yes, we can hear you.
So in relationship to the round magnets and the demonstration and how they were moving in relationship to each other, wouldn't those be primarily magnetical in their field demonstration?
Yes. If you had to turn one of those round magnets over, then you would get the other polarity, yes. I just wanted to show us as a demonstration how they move and interact, and how by moving one, the others move.
Great. Thank you very much.
All right, so we carry on. All right, so the next section is just going into the nano and what nano is. Just to get an understanding of the term dictionary of nano, it's a tiny, tiny 1 billionth or factor, or 10 to the minus 9 factor. So we're dealing with very tiny, tiny particles, what we call as the nano. So very, very tiny. In terms of the basic terms and definitions for nano, when we're talking of on a plasma basis, it's the individuality of tiny entities in nanoscale, such as atoms within a molecular structure, which are independent and dynamic. So nanomaterials are independent of temperature and pressure due to their individuality of atoms. And we'll explain that in a bit more detail. And that's the point where I need Flint to play the nano video that the Foundation has produced.
Okay, one moment here.
Yes.
I don't believe there's any sound. Do you want to read it as it goes through?
No, people can read.
Okay.
The transcribers could actually transcribe it, the words.
Yeah, I know.
which
Probably
would be
should. I'll
nice.
start it over here.
Translators later will have something to translate.
instead of silence.
Shall I
It
read
makes their job easier, but we should have compassion for those that like to learn what's in here.
Yeah.
Shall I read it?
Go ahead.
In the physical matter state, changes in the environment, temperature, and pressure result in different states of matter. Modifying the environment in a magnetic gravitational manner, we can convert physical matter state into monoatomic state, into nano layers. So you see the physical matter, and there are the monoatomic state nano layers. The caustic process of nano-coating is achieved by adding heat, water, and sodium hydroxide. The interaction of the environment with the copper creates a gap for the nanolayers to form. So you see the physical piece of copper, and it's in that caustic environment. So that caustic environment loosens the bonds between your different atoms so that they slightly reposition themselves. They're still attached to the matter, but they've changed their magnetical gravitational and have moved position from direct contact. So although the nanolayers form with gaps, both in respect to each other and physical matter, they're still connected to the matter, but they've positioned themselves. They're not free and independent from the physical matter. They are connected through gravitational magnetical field connection. So the physical matter state is densely packed, molecular attachment dependent on temperature and pressure. The monoatomic layer, nanolayer position themselves and are connected through gravitational magnetic fields. The nanolayers share connection to each other and to the physical matter structure. That connection is the fields. Nanolayer formation is replacement by positioning of the gravitational magnetic field strength. This occurs from the inner physical matter structure to the outer monoatomic structure. Atoms from the physical matter reposition themselves within the nanolayers, dependent upon the strength of their gravitational magnetic field. So they just find their position depending on their strength. These nanoparticles don't get stuck, they find a gap and accommodate each other. The gaps within the nano layers are not uniform. These magnetic field gaps hold capacitance and contain a spectrum of fields. This separation gap is energy of gravitational magnetic fields. The matter's part of the nanolayer continuously release fields to maintain this gap. This release of fields maintain their position and balanced presence in respect to the environment as well. These released fields amalgamate into the gaps, becoming the center of energy and information. These gaps are magnetic envelopes which contain the plasma within the nano layers. These nano layers vary in their gap and therefore field strength. These layers interact with each other, producing a vast spectrum of gravitational magnetic fields. They absorb all the spectrum of the magnetic fields, which is why they appear dark. The drying stage of the nano-coating process is a way for the layers to stabilize. The fields link to each other and find a balance. The use of a voltmeter during the drying stage aids the stabilization and connection. The electrical current aligns and establishes a line of flow through the nano layers. It is important to understand that nano layers are not two-dimensional. They operate in 3 dimensions. A successful nano-coating process on copper will result in the material turning black. This is testament to the efficacy of the nano layers in their absorption of magnetic fields. These nano layers are now tens of thousands deep. As nano layers are 3-dimensional, so are the magnetic field containers, the gaps. The breakthrough with nano layers is the creation of this magnetic field container. This magnetic field container holds onto plasma, energy, and information. Plasmatic magnetic fields are not able to be captured by these magnetic field containers. fields of matching strength with a magnetic field gap are attracted and link up. And that's the end.
Okay.
I'll share my screen. Okay, so that's a great video to illustrate what the nano layers, how the nano layers are formed, and why we need to create these nano layers. So as we explained in the first section, the existence and interaction of dynamic and different strengths, speeds, densities, magnetic fields leads to what we see as planets, galaxies, plants, animals, molecules, and atoms. So everything is fields. So how do we interact with these fields? So we interact with these fields through the nano layers. So we've gone from the matter state, which is our piece of copper, for example, and we have nano-coated the copper, and now we have the same piece of copper, but now it's got thousands of layers of nanoparticles on there. So if we just explain a little bit on what's happening in that video. So we know what the matter state is. Everything that we see that is tangible, we call it matter. Whether it was a plant, a piece of plastic, or a piece of steel, we've always known it as, well, that's matter. They are all made up of a structure which is little balls packed together. We call it matter, but in fact it should be called plasmas. We have these little balls sitting next to each other, tightly packed. These are like magnets, and when you put them next to each other, they will find their distance from each other. So that's essentially what our matter state is. And if you have a look at that picture at the bottom there, it could be a copper, or copper atoms sitting next to each other on a copper wire. So when we go to the matter, to the nano state, so if we apply heat or we put a current into it, if we apply heat through the caustic environment, it becomes separated and will look like this. So we can see that those tiny balls that were very tightly packed are released, and so they'll find their position, so they'll move further away from each other, still connected, but now they're further apart. And the copper wire then looks black, but we have at least 30,000 layers of these little balls on top of each other, and that's our nano layer that we create. And it's black because we're basically absorbing, it's able to absorb the full light spectrum, and that's why we see it as black. So why do we use these layers? So the nano layers are the interface, it's the connection to all the fields around us. It's these nano layers that allows us to start interacting with these fields. Because we have loosened the bonding between the atoms, It allows more fields to pass through these gaps. And we can also describe the nano layers as filters, because different nano layers will only allow certain fields to pass through. When we begin to understand how to really start making different nano layers for different purposes, you'll be able to see that they act as certain filters. And so if we only want a certain amount of certain type of fields coming through, that's what we'll create, so that only those fields come through. So there's just another picture to try and illustrate. So even in the matter state, if you had a look at all those little round atoms, each one of those little atoms still has its own magnetic gravitational field, but are very, very tightly packed. And so when we create that different condition for them, that bonding loosens, and so the tiny atoms move further away from each other, still connected with each other, but now we have those gaps between them, and then that's the gap that allows the fields from the environment to start coming in and interacting. And now we can understand why the paint pen works so well. It's because it's the nano layers on the copper wire which allows the fields of your body and the environment to flow through the pen, through the nano layers on that pen. In the next workshops, we will go through and show you the whole process to create your own nano layers on your copper plates, or copper wires. So the summary for the introduction to why we end up creating nano layers and what's the purpose of it is because these nano layers allows us to interact with the fields that are all around us. And these nano layers also act as filters, only allowing certain fields to flow through. And you'll see how this becomes quite important when we look in the health aspects for the body and for the plants, is that we get this filtering effect in our body and in plants and in the environment all around us. Questions relating to this introduction to the nano?
There was Dennis had your hand up there. Hello, Dennis. Want to introduce yourself and ask your question? Hello, Dennis. Can you hear me? Perhaps you can't unmute right now. Let's see here. If there's any other questions in the media streams. So someone in YouTube asks, so the attraction between magnets is now called gravitation?
Yes.
That would solve the unification theory.
It's different terminology for what we've been taught at school about attraction and repulsion. Now we can call attraction is gravitational and repulsion magnetical. So if we can just understand those concepts. Very important to understand.
Okay.
Shall we move on?
I'm just checking Facebook here. One moment. Yeah, Adam on Facebook asks, can we nano-coat anything at all? I think it means everything.
Yes, we will be showing you, besides nano-coating the copper, how to nano-coat your zinc, how to nano-coat your plastic.
Okay.
Even something like wood. So,
Food.
yeah.
Can nano-coat pretty much anything.
Yeah.
Okay, that's all I see for right now.
Okay, we'll move on. Okay, so we'll now go on to the third section, which is just going to be explaining a bit on what Gans is, that we've introduced in the beginning. Definition for Gans: it's a new state of matter, a molecule of a gas which becomes nano of itself and appears as solid state of matter. Gas to nano of solid is to be called Gans for short. We'll just explain a bit more about that. So we start out with the matter state, we create the nano, and we'll be showing you later workshops how you'll be creating your Gans material using different metal plates, one nano, one non-nano, to create your Gans material. So if we expose, a short example here, if we expose this nano copper and plain copper to another condition, like a saltwater environment, we create the condition for the Gans of copper to be created. These Ganses become free and are not attached to the copper anymore. And they become a Gans material in copper oxide. So now these are, you're looking at a picture of the jar with billions of tiny little particles, and those that have made their Gans already. Each one of those tiny little Ganses is now independent, and it's not attached to anything anymore, and they're essentially independent of themselves. And every single, if you can view every single one of these little balls is like a little sun, and is radiating energy continuously outward and receiving energy coming in. And if you view these little Gans as tiny little magnets, as we showed in the beginning video, as round three-dimensional, that's essentially what each one of those little Gans plasmas that we make. a single Gans, Magnetical, as Magnetical and Gravitational fields, because the fields are flowing out and the fields are coming back in. And each one of these is made of millions and millions of fields that come together and spin continuously, creating a dynamic field interaction. So that's what our little Ganses are that we make in our bottles. And each one is radiating continuously. So in the future workshops, we will be showing you, how to make your CO2, your copper, your zinc, and CH3, which is your four main ones. In how you collect your amino acids. In the health sections, we will be showing you creating the food Gans, calcium Gans, Gans of pills. So you'll see how we will show you that understanding the basic concept, you can begin to learn and do all this yourself on your kitchen table or in your garage. You'll be able to create all this material for yourself, and then we'll be able to use it in various ways for health and for agriculture and for energy. So the summary of what the Gans is if we view them as tiny little suns, say a tiny little round magnet that's constantly radiating, and because it's free, it's a tiny little entity all on its own, it's emitting a much stronger field than what it was being attached to the matter state, and is continuously giving and receiving fields. So that was a short one, but it was important to just establish the very basics of what the Gans is. And then we can open if there's any question.
Okay, looking at all of the boards again here. I do have one from last time I kind of missed. This is Maru from the Facebook feed. Did ask, how powerful is nano on the surfaces of the material, as well as physical resistance?
Well, the nano layers that one creates on your copper that's the two terms. It's highly conductive and, somebody can help me, insulating material.
Yeah, insulating or resistive.
Yeah. Now that's why if anybody's brave enough to, once you've made your MagRav and you connect it to the power grid, one can touch it without getting shocked, because those tiny nano layers insulate you. So they're insulating as well as highly conductive. It just depends on the direction of flow.
I have a question concerning the Gans.
Go ahead.
This is Boniface again. What is the difference between what they call the dry Gans and the Gans that would typically find in the liquid?
It will have different uses. In its dry form, I don't know if anybody else can help me on that one, but you just find sometimes it's used for different uses, because what's in the liquid has a certain strength, and when you dry it, you're changing that condition around it, so it'll have a different slightly different field strengths. Is anybody else, some of the students, that might be able to help? I know myself, when I had, by mistake, I was working and creating some of the capacitors, and I then touched, using my finger, and I touched my lip with the Gans material, and it was so highly energetic that made my whole tongue numb for quite some time afterwards. So it's not something to play around with lightly. It's very energetic. That's why we always stress to work with gloves and be very careful when you're working with the Gans material.
Brett had your hand up there. Hello, Brett. You have a question?
No, not a question, but in answer to Jim's question, what the differences between a dried and a non-dried. One you've dictated to, and the other you have not. And just so that everybody's aware, do never, ever, ever drink dried Gans. Whether it's in a glass or it's settled to the bottom or whatever, never drink it. I found that out the hard way. So one you've dictated to, one is still in a different state. So dictation means that you change the fields into to a different level. So it's very, very important that everybody understands that you never, ever, ever drink or have anything to do with anything that's dried in the way of drinking.
Thanks, Brett. I think, Flint, I'll move on to do a summary, and then we'll then open again for see if there's any questions. So
yes, go ahead.
So essentially, when we look at the summary for today, the whole purpose of these workshops is to keep it short, to the point, so that you can take home certain bits of information and really understand what it's all about. So the plasma science is really an extension of what we know. It's looking deeper into the essence of everything, which is the magnetic fields. And that's what you really need to understand, is that everything is made up of these fields. So even the pen you're holding or the table you're sitting at, it's all made up of fields. And we'll go into more details next time. But that's what you really need to take home. And it's the interaction of these magnetic fields creating what we call maggrav fields, which is magnetical and gravitational fields. So it's just a slight different concept from what we've understood as attraction and repulsion, but it's really magnetical and gravitational. We create nano layers, which allows for greater interaction with these fields that are around us, and how we can use them as filters so that we can only work with certain fields. And from those, we can start creating and producing our different Gans materials. And that the Gans, if you had to view the Gans as tiny little suns that are constantly giving and receiving fields. And it's this application and use of these Gans materials in the health and agriculture, and you'll see how it all starts fitting together under the different portions of science. And science today has really tried to compartmentalize everything. But when you start to understand the plasma, you will see that when you understand it from a health aspect, it's exactly the same in nature. It's exactly the same as the way the Earth works. It's exactly the same as the way our solar system would work, the galaxies or the universe. It's just a scale that would vary, but essentially it's all operating on the same basic principles. And that's very important for people to understand, is that the science merges everything into one basic understanding. It doesn't matter from the atom scale all the way out to the universe. It's exactly the same. All right, so those are essentially the basic points that one needs to take home from this first workshop, because they are fundamental to understanding everything later on. So if there's any questions on any of those three topics, then.
I would like to ask a question about Brett's dry Gans. Erik from Denmark. Brett said that we should never drink dry Gans. Is it dry Gans that is put in water again that you should not drink? Because I think it's very hard to drink the powder.
Yeah, no. What I meant, I'm very, very sorry, is you never put dry Gans into water and then drink the water.
Okay.
So thank you for clarifying that, because it took me a little while to get in because I put my hand up. So, but thank you for clarifying that. I really appreciate that. And you never, ever, ever drink the water of dried Gans, because there's still particles in it, and those particles are too strong. And as I said, I found out the hard way, and then Mr. Keshe warned me that you are actually physically drinking Gans, because those particles, unless they go through a what are those things that spin around? Oh gosh, centrifuge. You can never drink any water that's had dried Gans in it unless it goes through a centrifuge to remove the particles, because they're too strong for us. And as I said, I did find that out the hard way, and it really did affect me quite badly. So I really, really implore everybody to never, ever drink the water of a dried Gans.
Thank you, Brett. But I wonder what is actually happening, because do the particles themselves change? If we have the liquid plasma from the beginning with the Gans particles, when we dry the Gans, does this mean that the Gans particles stick together into a group of particles, and this group of particles, if we dissolve in water again, it will not get dissolved, so we get bigger lumps of Gans into the body, and that is why it's too strong for us? Or how is it?
That's my understanding. Is what happened to me, and I'll explain this to you, is that I did what I said that I don't recommend to do, and I found that I felt sick. The fields were so strong as it moved through my body that I literally felt ill, because the fields were so strong. So there's particles caught in the water that is too strong. When it's in we call it, I don't know whether we call it a matter state or whatever, when it's still in its standard Gans state, and then we drink the water, it's fine. But if you do dry it, there are still so many particles in the water that are so strong that when you ingest it, it really does make you feel ill, I promise.
I take your word for it.
Don't try it, trust me. Don't try it. It's
Okay,
not
well,
very nice.
we're getting into something here that we haven't even discussed how to make the Gans and Gans Water and so on yet. So this is a question that shouldn't even come up right now. The main thing is people are told, do not drink the Gans. This is the main thing. And if that includes You know, if you can't mix it so that it can not be ingested, then that's very, very important, of course. But this is something we haven't even discussed it in the teaching yet, so I don't know if we should be getting into the details of how not to ingest the GANs.
Yeah, thanks, Rick.
Yeah, I can add that as when you have the original ganses produced in the water, they are harmless to drink the water. You have to say this. It's only when you do more work on it you can get.
Well, you gotta say that in context, because is it harmless to drink the copper oxide Gans water? I don't think so. So you have to specify exactly what Gans water you mean, and in the context of when it is okay to drink it, and so on. We haven't gotten into that yet, into the teaching here. And you're telling people to start drinking Gans water, and that you've already drank Gans that's caused harm to your system and so on. So now people are wondering, what is this Gans water that causes harm? And yet we haven't even described what the Gans water is yet, or the creation of the Ganses and so on. So I think we're jumping ahead a little too fast here, and we have to let the public absorb the information we have without getting into, you know, we have to have warnings, yes, but we haven't even described how to make it yet, so we have to wait one step at a time, I think.
Yeah, thanks, Rick. Any questions relating to today's topics?
Jim, this is Boniface again.
Yes.
I just wanted to thank you for putting together this presentation. I can see how helpful it's going to be for those who've been around for a little bit, and especially for those coming in new, because I recall how I was scrambling trying to figure out how this whole thing was about when I first came to the knowledge. So I really appreciate you doing this, and I'm looking forward to what's coming ahead. Thank you.
That's a pleasure. It is important because we all know there is so much information out there, and myself, it's taken a long, long time. It's 2 years of study to try and get a handle on all of it. So if we can make it easier for future people coming along, then all the better. And that's what these basic workshops, are all about. It's just to lay a good foundation for people, so that when they do start watching other YouTube videos, and that, then at least they have some understanding of the terminology and what has been spoken about. So, any other questions? Yeah.
This is Peter again. And I too want to thank you and appreciate getting back to the basics and having this step by step. And my question has to do with, will this be available on YouTube for review before next week? And also had some other people that I wanted to share it with that are actually working at this time. So I just had that question in regards to, will this be available?
Yes.
Yes, it will. Yes. It'll be available on YouTube, Facebook, and our live stream channels. So, yes.
Lots of choices. Thank you so much.
We have, yes, thank you, Peter. A question here from Sismaro Gabriel on Facebook, asking how powerful is nano on the surface of a metal piece, as well as physical resistance?
If we look at physical resistance, the nano layers are really, really delicate, especially when you make them in the beginning. You can, if you're not very careful, you just crush those layers. One has to really set them, let them dry for a good 3-6 months, and then they become a really, really hard, sort of almost diamond structure, diamond hardness. So it's to create really beautiful nano layers takes a lot of time. It's not something that we can rush and make in a weekend.
And it's also good to note that plasma, the nano layer causes unidirectional, or sorry, the nano layer causes unidirection of the plasma flowing through it. Either if it's flowing with the plate or with alongside the metal, becomes a superconductor, and if it's at perpendicular to that, it becomes a super resistor.
Yeah. So that's why it becomes so important when we'll explain when you make your nano layers why attention to detail is important, so that you can get it right, so that you.
Jim, this is Dimitri. May I ask a question about Gans filtration?
Is it relating to the topic?
I believe, well, it's about filtering.
Filtering of the Gans?
Yes.
Let's leave that for later on when we get to that. Thanks. No more questions?
Giving you one last pass over here.
Okay.
That seems to be it.
All right. What we'll do next week on part 2 is when touch on the health aspects, nature and the soul. And then the 3rd week we'll then come back to plasma, nano and Gans, but then we will start adding and building more knowledge onto what you've already learned. And so that's how we'll be going through the series of 12, is just building that knowledge base on top of every week. And then you'll be able to see how everything starts relating, say, understanding health and nature and just how your soul operates. It's all the same. So hopefully we'll be able to,
Jim, there's a question here. Is there a copy of this, of the PowerPoint file available? And
all these will be going to all the different language teachers. They'll be getting copies of it so that they can use it to all the different languages around the world.
Will the English one be available to the public?
Yeah, I think so. I'll just check with everybody first, but I don't see a reason why not.
Okay, maybe in the next workshop we can let people know where that can be found. Then
we will put them all. Yes.
Mm-hmm.
If there's no other questions, then we can wrap it up. As I say, I want to keep these as relatively short, so that you've got to think of the people that are going to be watching them later on, so that at least they can spend a short amount of their time just to get to the nuggets of this information. So thanks everybody for attending and helping today.
Yes.
Thank you, Flip and Rick.
Thank you, everybody.
Thank you, Jim. Thank you. Thanks, Rick.
Yes, thank you, Jim, and thanks, Rick, for your help. Wonderful session today. This has been the Keshe Foundation Spaceship Institute Public Teaching in English for Monday, September 25th, 2017, with Jim McDonald in our debut of our new series, Understanding Plasma Science. We'll see you next week at the same time, same place on this public channel for Zoom. Monday mornings at 10 a.m. Central European Time. Everyone have a good rest of your day, afternoon, or evening, and we'll see you next week. Bye for now.